So today it's my pleasure to welcome Bryan Costanich, who is Director of Education at Xamarin. And Bryan is going to talk about cross-platform mobile development with C#. Please help me welcome Bryan.
Thanks, guys. Awesome. So yeah, hopefully you guys will enjoy this. That's cool. That's cool. Man, it's been kind of nice weather. I was really, I'm not gonna lie, I was really sort of scared of coming out to Scandinavia at this time of the year. So I'm speaking at OrDev next week. I have a couple of talks. One is going to be on this stuff, and then another one's going to be kind of an advanced architectural patterns and things in Android. And when I booked this, I didn't realize that it was, when I was invited to OrDev, I didn't realize that it was in November. So I was here, I was in Scandinavia a couple of months ago, and it was just beautiful. We bought a little company in Aarhus, Denmark. And so I was over visiting with those guys and working with them. It's our test cloud product. And then I popped over to Sweden and then did like a 4-city roadshow, which was sort of kind of, while I was there, I wound up doing these talks. And it was gorgeous. It was absolutely beautiful. And then last week I'm sitting in Los Angeles, and it's like 80 to 85 degrees, which is, I don't know, like 30 or something. And everywhere else in the world, we're left over on the metric system. I don't know why that is. Actually, interestingly enough, the reason why America is still on the metric system has to do with housing. And basically it's a construction lobby that has lobbied to keep feet and inches, even though a large portion of America, certainly all of the technology and scientific community has switched over to metric. The housing development folks have kept us on feet and inches. So we can't do math at all when it comes to measuring things, and that's all because of the lobby system there. So anyway, I'm sitting there, and it's 85 degrees, and I'm like, yeah, next week I'm going to be in Scandinavia, and it's going to be really, really cold, and it's nuts. It's rather pleasant. So I'm happy about that. It was a little rainy, but I'm from Seattle originally, so I'm used to the rain. So I'm from Xamarin. My name's Bryan, and this is how you can get a hold of me if you ever want to. Feel free to email me anytime you guys have any questions. It's Bryan C, that's Bryan with a Y, at Xamarin.com. And you can find my mad ravings on Twitter. I'm just at Bryan Costanich. And then these slides are actually up on slideshare.net. So it's just slideshare.net whack Bryan Costanich. And I encourage you to pull them down because there's a lot of good stuff in here. We're going to do a lot of guidance and whatnot around mobile development, cross-platform mobile development in C#. So the first thing I want to do, I want to show you guys a little demo. I want to show you how awesome C# is. So how many, just as a quick show of hands, how many people here are C# developers? I assume that since you're at Microsoft, most of you. All right, so there's a few that aren't. That's interesting. You guys are like Ruby developers or Python or like murmurs. That's cool. Murmurs is better than murders, I suppose. So I want to show you something. Do you guys are you familiar with the Agent Watch at all? The Agent Watch? No? Okay. Well, how many people here are familiar with .NET Micro Framework? All right, so about 10 of you are familiar with the .NET Micro Framework. Okay, so how many people here know what Arduino is? All right, so about twice as many people know what Arduino is as the Micro Framework. That's sad because we're at Microsoft. So the .NET Micro Framework is a very, very slimmed down version of the .NET Framework, and it runs on microprocessors. And this is really, really cool because if you want to build robots and you want to write your robot code in C#, you can. So the .NET Micro Framework has, it runs on these, it runs on little microprocessors that are built into boards, and there's a couple of really popular ones. There's NetDuino, and NetDuino is based on the Arduino form factor. So anything that was built for Arduino will pop right into the NetDuino and is largely compatible. And then there's like Fez Panda. This is another popular board. But what it allows you to do is integrate with sensors and servos and motors and that sort of thing. So you can actually go out and build robots and interactive art displays and whatnot. You can get yourself into a lot of trouble. In America, we had this, I think it was in Milwaukee, these guys, was part of an Adult Swim, which is this a network, a cable television network, and they do kind of like offbeat, off-color cartoons and stuff for adults. And they did all these interactive displays in which they were space invaders, and they were like LED light-ups, and they put them on bridges and things like that, and it wound up being kind of a big fiasco because the Homeland Security Department stepped in and thought this was some sort of terrorism threat. So evidently we were going to be invaded by LED aliens. Anyway, so you can build things like that. You can get yourselves into trouble, or you can build robots and whatnot. And one of the things that's cool about the .NET Micro Framework is that it actually allows you to do live debugging on a microprocessor, which is unheard of in the microprocessor world. So this is really, really cool. And I really like developing robots and stuff. And I'm good friends with the CEO of NetDuino. His name's Chris Walker. And Chris, those guys decided to create a smartwatch. And the smartwatch is called the Agent Watch. And so this is a picture of it here. And I don't know if you're going to be marketing a watch, you should probably show a better picture than the battery charging symbol. But they're clearly not marketing guys. But I'll say this. So they did a Kickstarter for this thing. And this watch runs the .NET Micro Framework, so you can use C# to build applications for it. And there's two kinds of things that you can build. One is watch faces, so you can build like specialized custom watch faces to your liking. I think they have some photos here of some kind of boring ones. But you guys can come up with way better watch faces than this, I'm sure. But the other thing that you can do is build applications for this thing that run the .NET Micro Framework. And the watch has like an accelerometer and some other sensors on there and whatnot. So you can build these apps that run on the watch and then integrate with their sensors and the other things that are on the watch. And then you can communicate via Bluetooth to your mobile devices. So if you're building for Windows Phone, then you can write C# apps with Windows and communicate with this thing. And if you're if you're using Xamarin, then you can do C# apps for iOS and Android, which I'll talk about in just a bit. But what's amazing about this is that they had a $100,000 goal on Kickstarter. So they're like, well, how are we going to fund this thing? Well, we'll do a Kickstarter campaign. And so they were like, how much are we going to raise? And they came up with this $100,000 number, which was enough to sort of get the prototypes out and get this thing into production and whatnot. And they thought they'd have a really hard time raising this money. So we were working with them, Xamarin and Secret Labs. And Secret Labs, by the way, is the name of the company that makes NetDuino and whatnot. So we're working with them and on the marketing beforehand, and we're kind of doing some joint stuff, and we were doing a little bit of strategizing on how they're going to raise the money and whatnot. And it turns out they didn't need our help at all because they launched the campaign, and within 11 hours they reached their $100,000 goal. And at the end of 30 days, they broke $1 million, so 10 times the original amount. So I think that's pretty cool. I think it means that there's a lot of people out there that are building in C# that want a smartwatch, and a smartwatch that doesn't suck. So I think that's pretty cool. So I want to show you something here. these guys released an SDK. And the SDK, sorry, something in my throat. The SDK allows you to build these apps in Visual Studio, and then you can run they have an emulator. So let me switch over here and show you this. So here's an Agent Watch application, and it's very simple. So here we have our static void main class, and I'm newing up a couple of, I've got a couple of class level variables here. I've got one for the display, which is just a bitmap, and then I have one for a serial port. And the way that this communicates via Bluetooth is one of two ways. Either you can talk to it via Bluetooth LE, or you can use serial port profile in Bluetooth. And in either case, when you're writing the apps, you use a serial port class here to talk over Bluetooth. So this is very simple. Here I have my static void main. I create a new bitmap. I draw some text on there. And then I open up a serial port and I start listening to the data received event. And in my data received event, while I'm listening to this, I have this helper method that I call called readString, which basically takes the bytes that come through the serial port buffer and then convert them into a string using a system.text encoding. And then I also have a method here called sendString, which does just the opposite. It takes a string and then encodes it via UTF-8 and then writes it out to this serial port. Now, please don't judge me on the code. It's probably not fair. It's probably not the most efficient serial conversion code out there, but it does work. And I want to show you this. So, as I said, it comes with an emulator, and this is pretty cool. So you hit the big button, as your brother Anders would say. You come and hit the big button, and up comes our watch. And what's really neat about this is that I can expose this watch as a COM port over Bluetooth on the laptop. So I can actually connect to the laptop as if it were the watch. So while the prototypes aren't available yet, I can still pretend that I have an actual watch. And if I switch back over here, I have a Xamarin.Android application. And we'll talk about what that is in just a sec, but for right now, we'll just say that this is magic. Oh, it didn't switch. Great, now we're switched. So I have a Xamarin Android application, and it's running on the world's largest phone. It's funny because I had to go get a 4.3 device, so the latest Android, or well, was the latest Android until yesterday when KitKat came out. And I went down to the store and they're like, well, this is the only device that we have. And I'm like, that's not a phone, that's a tablet. It's enormous. So this guy is an Android application written in C#. And on here it has a list of all of the Bluetooth devices that I'm paired to. And so I have this one called Bryan Yoga. And please don't judge me on the name. I'm not a yoga junkie. This is a yoga pad. And I didn't think when I named it Bryan Yoga that I would be up here trying to explain why my laptop is named Yoga. So I connect to this to my my laptop here with my mobile application, and then I've got a couple of little I have an input and an output here, and what I can do is I can type in a message here. So I'm going to say rotten in Denmark. Right, little Hamlet reference. That's evidently just up the road here, Helsingør Castle or something. I guess that's the town. The castle's called something else. It's okay. I think it's okay that Shakespeare got it wrong. So here it is. I sent my text, and it says Rotten in Denmark, and it says message from headquarters, Rotten in Denmark. And then what I do is I call a method in there, my send string, and I send it back here, and it says Agent 007 acknowledges message, Rotten in Denmark. And I think this is pretty cool. So what we just did is this is an application or a set of applications that end-to-end are talking to a computer on your wrist and a computer in your hand, and it's all in C#. And I think that's really fantastic. I think it's fantastic because it's all part and parcel of kind of a message that I think is important, which is that C# is really available everywhere now. So you guys are familiar with C# in the traditional Windows ecosystem. So you can write C# apps and you can put it on your web server running Windows. You can put it on your Windows machine, etc. But now via Mono and via Xamarin, C# is really available in a lot of different places, and then also through the .NET Micro Framework. So the NetDuino guys. So how many people here, just as a show of hands, how many people here know what Xamarin is? All right, so about 2/3 of you. That's great. So this presentation, it's going to be broken up into kind of two pieces. The first part I'm going to explain for the third of you that don't know, have never heard of Xamarin and never used it, kind of what it is and how it works. So what's the magic behind it? And then the second half is going to be about mobile architecture and best practices and whatnot. But like I said, this is really amazing. So Xamarin makes a platform that allows you to build C# native applications on iOS and Android. Now, you can also do, we also have a Mac product, so you can build C# applications for Mac. And then via Mono and the items that are built on Mono, you can also target things like the PlayStation, you can target the Ouya, and all kinds of different platforms. And we're gonna look at that a little bit in a sec. But I think it's really rad because I think that C# is probably the coolest language on the planet right now, along with the .NET framework. It's funny. I'm sitting with a friend of mine in San Francisco, and he's a CTO of a tech startup, and we're talking over there because C# is not super sexy in San Francisco right now. Everyone wants to build Ruby applications, and then they start building Ruby applications, and they get to a certain size, and they're like, "Hey, wait a sec, our Ruby application's falling apart." And so then they typically upgrade to some sort of enterprise solution, either Java or C#. But it's really interesting because I think right now what's happening is a sort of resurgence of C# and .NET. I think that a lot of people tried some different things, and now they're sort of coming back to C#, and it's becoming cool again. And I think a couple of things are doing that. One is things like NetDuino, the NetDuino platform and .NET Micro Framework. And then also, I think some of the work that we're doing over at Xamarin has been really interesting because it's brought C# developers to the mobile platform outside of Windows, because it's already available on Windows Marketplace. But for iOS and Android, if you want to build C# apps, then Xamarin's pretty much your only option out there. So today we're going to talk about that, and we're going to go through some sample code you can find up on GitHub. So we're going to take a look at a very simple cross-platform application called Tasky. And what Tasky is a simple to-do application that runs on iOS, it runs on Android, and Windows Phone. And so it's just a very simple application that allows you to make to-do lists and whatnot. And it shows how to share a common set of code across these different platforms. And you can find it up here on our GitHub account, so github.com/Xamarin mobile samples Tasky Pro. And then the watch code that I showed you before, so that application, both on the watch and then in the Xamarin.Android stuff, all that stuff's up on blog.xamarin.com, and just search for Agent Watch, and you'll see I did a whole write-up there. So definitely check it out. So the Xamarin platform. So about 2/3 of you guys know of Xamarin. How many of you are actively developing or have developed with Xamarin here? There's a show of hands. Okay, so looks like about 9 of you. All right, so for the 9 of you, this part might be boring. And for the rest of you, the 95% rest, this hopefully will be kind of interesting. So as I said, we allow you to use C# to build mobile apps for iOS and Android. And I think we all know C#. C#'s awesome. But one other thing that we allow you to do is now we support F# as well. And F# just blows my mind. Every time I have to use it, or every time I try to use it, I have to relearn it. You guys, how many people had those Casio graphing calculators back in high school? Did you guys have them here? All right, a couple of you. So I had this graphing calculator. It was by Casio, and everyone else had the TIs. And the TIs were pretty normal and easy to use and stuff. And then the Casios use this thing called reverse Polish notation. And reverse Polish notation was like the weirdest thing to me, because it would be all of the things in your equation, and then your operators, and then you'd hit the button. So it'd be like 5, 7, 8, and it's plus and divides, and then you hit the button, and somehow it manually magically parse this out, and then would be amazing. It was a much more powerful calculator than the TIs, but it took a while to learn, because you had to take your brain out of its socket and just turn it around backwards, and then you're ready to use this calculator. F# reminds me of that, because F# is an amazing language. It's incredibly powerful. But every time I have to learn it, I'm like, oh my God, I'm not smart enough for this. But we do allow you to do F# on mobile devices, which is pretty cool. So if there's any F# aficionados in the house, know that we support it. There's some magic here in what we do. Xamarin's platform is not a write once, run anywhere sort of thing. It's not a phone gap. It's not an accelerator. It's not an interpreted platform. We actually compile down to native assembly code. And it's a little bit different between iOS and Android. And there's a little bit of magic on both. And the way that it works in iOS is that when you hit the big button and you compile your application, we have this thing called the AOT compiler. And AOT stands for ahead of time. And as opposed to a JIT compiler, in which you deploy your app with an IL package, and then it compiles and then runs that way, we actually compile directly down to the processor architecture code when you compile your app, which is really, really cool. So we go straight to like ARM v6 or ARM v7 now when you compile. And this is kind of magical. And what this means is that you can run native applications on iOS and write it in a language like C#, because the processor architecture of iOS and also of Mac is such that it doesn't allow you to emit code into memory and then execute it. So JITting is not really possible without some sort of interpreter, which is traditionally very slow. So we get around that by going straight to assembly when you compile. So that's pretty cool. And then on Android, we have a traditional IL path. So you hit the button, it creates an IL package, and then you deploy it. And then what happens is it executes and compiles, or compiles the first time you execute. And the way that this works in Android is that we actually ship the mono VM side by side with the Dalvik VM. So they sit side by side and they coexist in there. And most of your application execution happens in the mono VM, and then when we have to invoke stuff in the UI and whatnot, we call over into the Dalvik VM. And then also a lot of graphics calls and whatnot are going straight to the Linux subsystem. And what this means is that on both platforms you get incredibly fast performance. And in fact, on Android, for most apps, we're faster than the native or the indigenous Java apps, because our VM is much faster for most most processing than the Dalvik VM. So this is really, really cool. So people have used our platform to build games even on this, and they're very performant. You know, there's no lag there. It's not like you hit the button and then you wait and then the button, you know, pops or anything like that. It's very, very performant, and it blows my mind. It's funny. Will Ferrell, like a couple of months back, he tweets. He said, you know, in the palm of our hand now we have computers that are 10,000 times as powerful as the computers that sent astronauts to the moon, and we hurtle angry birds at pig houses with our devices. So that's what we're doing with all that processing power. But I think it's pretty incredible because someone has gone out and they built a flight simulator app. That runs on Xamarin, and it runs on the iPad and the iPhone. It's called Infinite Flight. And I remember when I was growing up, and one of the fastest computers I ever owned was like a 486 DX266. And this thing, I had Flight Simulator on there, and I was trying to, you know, fly my little airplane and stuff, and it was just chugging along, and I'm like, oh man, this is really painful. And now with the iPhone, you can load up Infinite Flight, and you're like, oh yeah, this is really nice. And it's very smooth, and you know, there's no flicker, and it's not like chug, chug, chug. I think that's incredible that our personal devices have become that powerful. And with Xamarin, you don't sacrifice anything through through some sort of interpreter stack. You get native performance. The other thing that you get here is that you use all of the native UX toolkits. So again, instead of having something that sort of indirectly uses the native stuff or in a web browser or something, you actually are using the underlying platform SDKs. So in iOS, you would be using UI Toolkit or the UIKit namespace, and in Android, you'd be using Android widgets and whatnot. So you're using all the native stuff. And even in terms of like native platform calls, if you want to do core animation or core Bluetooth in iOS, or you want to write interactive wallpapers, etc. in Android, you can do that because we expose the entire underlying SDK, and on top of it, what we've done is we've projected it through really nice, strongly typed C# bindings, which give you IntelliSense and things like that, so you can navigate through, and it's a very nice, it's a really nice experience. And then we also allow you to invoke directly into the indigenous runtimes. So in iOS, we allow you to call selectors directly if you want, and in Android, you can use the Java native interface. So you can do JNI invokes. And what this all amounts to is an amazing code reuse story. So not only do you get to use your C# code that you've had around forever and all the C# libraries that you've built or that you've come across, etc., but you can also, we have binding projects for both Objective-C and for Java. And this is really cool. This is something that we've had for a while, but we recently made them even better. Before, it required a lot of hand wrangling and stuff, and a little bit of work to get these going. And now you point at a library and you hit the button, and it goes out and it examines that library and creates a wrapper for you. And then you just have to do little tweaks here and there. And now you can use your Java jars that that are out there. You can use Objective-C libraries that are out there to do all kinds of interesting things. And this is really cool because people have devoted a ton of effort out in this space, and they've built a lot of really, really cool libraries. So, for example, Facebook has published a lot of their UI libraries through various means, and in the Java land and Android, people have built a lot of cool UI controls and whatnot, like flyout navigation, etc. And now those things are available to you. You just simply have to wrap them. And in fact, we've actually done a lot of the wrapping for common controls and common libraries already for you. But if you have your own, then you can use them. And then, of course, there's you can still p-invoke. So if you have C libraries, you can use the same mechanism that you've used for years in .NET in doing p-invoke. And then we've got this new thing, which is really, really cool. if you want to use C++ libraries and you don't want to go and create a COM wrapper for them, you can use CPP#, which is a Mono project. How many people here have actually created COM wrappers for C++ projects to integrate them into your apps? So a couple of you, so a few of you. What's that been like? Right? So for those of you who have never done that, it's a nightmare. There's a lot of stuff that isn't supported that way, and it adds a bunch of overhead, and it's just a real mess. And so we've gone ahead and we've gotten rid of all of that stuff with CPP#. And this again is largely automatic. So what it does is it goes through and it looks at your header files in your C++ project and then builds a wrapper based on those header files. And it's relatively painless. And that's really cool because there's a ton of amazing C++ libraries out there, especially if you're doing like math and physics and statistics. There's been the academic space has put a tremendous amount of effort into these libraries for the last 10, 15, 20 years. And so now you can use them. You can do really, really powerful computations and then wrap them and use them very easily. And then, of course, as I mentioned before, it's available on a lot of different platforms. So in Windows, we're used to the Microsoft stack there. If you want to build Mac OS X applications, we have Xamarin.Mac, which shares a lot of its core with Xamarin.iOS. So it's very familiar. And then also, if you want to build, if you're doing C# stuff on Linux, then you have Mono. And then with things like Mono Game, which is the formerly of the XNA toolkit, the XNA wrapper stuff, the Mono XNA stuff, you can reach out to Ouya and now Xbox as Microsoft's discontinued their own XNA toolkit. Now they're pushing towards people towards Mono Game, which is the Mono version of it. And then also PlayStation Portable, PlayStation 3, and now PlayStation 4, etc. So this thing's really everywhere. It's my little platform joke. That's Mario. It's a platformer. It's cool. As long as it's funny to me. So then, as you guys know, the C# community is amazing. They're largely more washed than these folks, I think. I think C-sharpers generally shower. I'm not sure if these guys shower too much. But there is a huge C# community, and now there's also a huge Xamarin community. So in fact, we have some of the top tags on Stack Overflow, and then we have very active forums at forums.xamarin.com. And the employees of Xamarin spend a lot of time there, and you can find us there. You can also find us on IRC and chat.xamarin.com, and then we also have great support. So point is here is if you run into things, then you can always get help. We also have tremendous documentation. We have some of the best documentation, I think, in the industry. You can find that at docs.xamarin.com. And like I said, our support is really good too. So if you do run into issues, it's easy to get help. And you've got an IDE choice here. So if you're used to Visual Studio, then you can use Visual Studio both for iOS and Android development. And then also you can use Xamarin Studio, which is a free open source IDE. And it's really a very nice, a very modern, clean IDE, and it's full featured just like Visual Studio. So all the things that you're used to with autocomplete and source control integration, etc., it's all there. And beyond that, we have something that's really, really amazing. We have the best designer for Android in the industry, and we're about to release something that makes it even more amazing. But one of the most painful things about doing Android development today is that if you want to use a designer, the designers that are out there are just terrible. In fact, a lot of people who are still doing Java Java Android applications use our designers because our designer is so much better than what's out there. And we also have an iOS designer, which is in the alpha channel right now. And we're hoping to launch that sometime early next year. And the iOS designer is great. How many people here have done Objective-C iOS applications? All right, so a few of you. So interface builder. You're shaking your head. So interface builder is really interesting. That's the part of Xcode that allows you to do IDE development for Mac and also for iOS, and it's really interesting. Xcode is like such a throwback to the 80s. Everything about Objective-C really, but also Xcode. So a bit of history there. When Steve Jobs got kicked out of his company the first time, he went and created this another company called NextStep, and NextStep they created an OS for doing graphics and stuff, and then later Apple purchased NextStep, and Jobs came back into the fold. But while he was over there, he basically created Objective-C and all of the ecosystem around it. So when you're building Objective-C apps, everything's like all the objects and stuff are prefaced with NS. So there's like NS object and NS this and NS that, and that actually stands for next step. And it's like a lot of legacy stuff from the old NextStep company. And it's funny because when you're using Xcode and you're writing Objective-C apps, like it becomes really obvious that there's a lot of things going on here that were really like high technology in the 80s. So one of the things that they have in Xcode Interface Builder is this thing called outlets. And what an outlet is that, so if you're building IDE, UI in any .NET framework, you know that you drop on a control and then you add an ID to the control, and it's available in your code. Right? It's very, very simple, very easy. It's very intuitive. Apple works a little bit differently. So what you do is you drag a control onto your screen, and then it's not available until you create an outlet. And what an outlet is how you create an outlet in Xcode is you hold down Control. Well, first of all, you have to open up two editors. They have a side-by-side editor, and it's the assistant editor. In Xcode, there's this little icon of a guy in a tuxedo, and you hit that, and it opens up the header file for your interface. And you then hold down Control, and you drag your control over into your header file. And that creates an outlet, which allows your control to be accessed in code. And I don't know who thought that was a good idea. Maybe in the 80s, there was a lot of cocaine back then. I think that was probably like one of those cocaine-fueled ideas. Hey, Bob, I got this thing. This is what's going to happen. I'm going to drag the control to your header file. And they're like, yeah, that's great. So it's a long story to say that we've gotten rid of all that. You don't have to do that anymore with the Xamarin iOS designer. You drop on a control, you give it an IDE, and magically behind the scenes there is an outlet. So it's very easy to use, and it's very familiar for .NET developers. And you don't have to do cocaine to develop Objective-C apps. Although you still can. I mean, if that's your thing. It's still available to you, I'm sure. Maybe you go down here to free Christiana land or whatever it is over in the. Yeah. So the point is, I think Xamarin's pretty awesome. I don't know if it's awesome as Mr. T. Mr. T was pretty cool. But yeah, the platform is really cool, and I encourage everyone to try it and love it as you will. But I want to move on. So now that we are all experts in how Xamarin works, I want to actually move to the second part of this talk, which is, okay, so I'm going to try Xamarin. How do I actually go about building these cross-platform apps? So let's talk about it. Let's go into some guidance and whatnot. So the first thing I want to talk about are like general cross-platform development and design considerations. And the first thing that I want to tell everyone is that when you decide to build a mobile app, you need to design the app for the platform that you're going to deploy it to. Because the UX across these different devices is fantastically different. They have different metaphors for how you interact with controls on screen and navigation and whatnot, and they have different sets of controls, etc. And people expect high quality applications, mobile applications. And the reason why is that mobile development and the mobile app space has been a great democratizer. It's kind of like the internet. There's a ton of applications out there, and there's a ton of really, really good applications out there. The barrier to entry was very low in the beginning, in that anyone could go out and create a mobile app. And it sparked a lot of creativity because there was also a lot of money to be made, especially in the early days. And the bar has been set very, very high. And when you're creating these mobile apps, if you don't hit a certain quality level, people simply reject them. Your apps don't get the adoption rate is very low, the usage rate is very low, and unless you have like a 4 or 5 star rating in the App Store, people will probably pass over your app. And one of the things that gives apps low ratings is if they don't feel right on the platform. And so we talk about these things as being like a native feel or native applications. And a good example of that is, a simple example is navigation. In iOS, there is the ever-present nav bar for hierarchical navigation. And on the nav bar, there's a back button. You can't see it here, but there's a back button here, and that's how you navigate backwards. Because the only button, besides the volume button on your device is your home button. So there's no back button. But on Android and in Windows, there is a physical or a soft button now in Android that is ever present. And so because the hardware is different, the UX is different, the metaphor is different. So in Windows, you have the panorama where you're swiping through different things. In iOS and Android, you have the tab bar, or you might have a flyout controller, which comes from the side. So these things beget a different interface and a different feel on the different platforms. And so this sort of write once, run anywhere approach can be very, very, very problematic. And there are a set of applications where that works, usually in like form-based applications where it's kind of like database entry and whatnot, and there's not, it's kind of an enterprise usage where people don't really care what the app feels like or looks like. It just needs to work, and that's fine. But if you're developing apps in which you are trying to get adoption and you need to convert people to your app, then they have to be high quality, and they really should feel like they belong on the platform. So they shouldn't feel like, oh my God, what is this? Is this an Android app that's been ported to iOS? Or on Android, is this an iOS app that was ported? Because it certainly feels like it. Why is there this back button up in the nav bar when I got a back button on my device? There's limited screen space there, so you want to use it wisely. The other thing that is really smart to do is to choose your device targets when developing. And it's interesting because even within a platform, the devices are different. And so this is a screenshot from the Mobile World Congress app that we developed as a cross-platform sample. And this is what it looks like in the iPad, and this is what it looks like in the iPhone. And you'll notice that because you have so much more screen real estate here in the iPad, you can actually fit like 3 screens worth of information in one screen. And in fact, you could probably fit 4 depending on how you're doing it. But that effectively makes these applications different applications, at least from a UI perspective or from a UX perspective. And so when you are developing these things, if you go out and you say, hey, I just want to, I've got this amazing app, I want to develop it, and I want it to work on every device out there, you're going to be in a world of hurt. And so what we do is we recommend to start with a limited number of devices. Start with a particular platform first. Even if you know that you're going to be building a cross-platform application, start with iOS or start with Android or start with Windows, get it right there, and then figure it out, and then port to the other or create the other platform applications. And this is especially true in Android land, where there's something like 1,200 common devices out there, and there's thousands and thousands of potential devices that your Android app could run on. And if you decide out the gate to have your app work perfectly on every single device out there, you're going to spend a lot of time just trying to get it to look right on any of them. And so what I say is, look, it's better to have a great app on a few devices than to have no app on all of the devices out there. So the pro tip here is to pick a target and try to minimize when you're at least first developing an application or designing an application. It's better to launch and get your app to market on a few devices than on zero. The other thing that you want to do is that you really need to test your app on the devices that you expect to deploy it to. Now, devices, we've talked about how they vary between platforms, but even within a platform, devices can vary drastically. We talked about the difference between the iPhone and the iPad, but beyond just a screen size difference, there's also hardware and device capability differences. So, for example, one device, one phone might have a camera, might have a front-facing camera, it might have video capability, and another device might not have any of those, or it might have some of those, but not other ones of those. And in the Android space, it gets even worse because the APIs can actually differ between manufacturers. And the reason why is that the way that Android works is that Google creates a reference Android OS. And then each vendor out there, each phone manufacturer goes and grabs this reference OS, and then they customize it to their devices. And they can actually change APIs, and they can change the way that APIs work. There's no contract there that they have to have fidelity to the original reference. And in fact, point of reference there is that if you go and grab the camera code from the developer.android.com site, you grab the code that they say, hey, this is the code that works to take a picture. If you grab that code and then you copy it to a bunch of different devices, I guarantee that it's going to fail on some of the devices out there. Because the camera APIs, turns out, can change between different devices. So it's really important to test early and often on an actual device. The other thing that's important here is that the emulator or the simulator that runs on your computer is not the device. It's just not. With the simulator, with the iOS simulator, that thing runs in an x86 processor architecture, and you have access to all of the RAM that's on your computer and all of the hard drive space that's on your computer. So let's say you're building a photo browser application, and you're loading up all of these photos. and you're using it in the simulator, and you're like, man, this is really awesome. It's really fast. It's like super snappy. My photos come up, and I've got no issues. And then you go and you deploy it to your device, and you load 4 images. And first of all, the images are loading really slowly, and then you load 4 images, and it crashes, and you get out of memory error. And you're like, wait, what's going on here? Well, you're not running it on a computer anymore. You're not running it on a laptop or a desktop anymore. You're running it on a mobile device, and the constraints are much more strict. So you may not have the 8 gigabytes of RAM that you have on your computer. You might have 1 gigabyte, or you might have even less. So it's really important to test those. The other thing is that, like I said, in the simulator, the architecture, the processor architecture is different. And so when you're compiling, certain things work in the simulator that won't work on the device. So it's really important to test there. And it's one of the things that we've done. We have this new product called Xamarin Test Cloud, and I mentioned this before. This is an Aarhus. This is actually a Denmark-based the company that we purchased, and they have this thing called Calabash. And Calabash allows you to run Cucumber tests on iOS and Android devices. How many people here have heard of Cucumber or behavioral-driven development? Okay, so a few of you. Okay, so what this is Cucumber is originally a Ruby-based framework that allows you to write UI acceptance tests, automated UI acceptance tests. So basically, this framework will go in and will click buttons on your interface, and will enter text, etc., and do all of the UI interaction and allow you to automate it. And then what you do is you write your tests in a business language. So you say, you might have this credit card validation feature, and you say, given a user enters invalid credit card information, then an error will display. And then what happens is that you write some definitions behind that, which are kind of like code behind for the tests. And then that translates the business language into what's actually happening in the UI. So what that translates into, okay, click on this input, enter this credit card number, hit the button, and then you should expect this particular screen, or this result, or this control should be up on the screen, etc. And then you can automate that. So as part of your development lifecycle, after you build, you can deploy, and then you can run these tests automatically. So you can kick them off locally, it will deploy to your device, and then run these tests. And it can run them across a number of different devices. And so what we've done is we've created a cloud offering that has hundreds of different devices, and you upload your application and you upload your tests, and then it runs those tests across all those different devices. So you get to see exactly what your application looks like on these different devices, and then also the results of all those tests. And it's interesting because as you're developing these applications, you'll find that different devices will display things completely differently, or they just act completely differently. So being able to deploy these to all these different devices without having to go out and purchase them on your own, and then manage that infrastructure and stuff is great, because you can see, oh man, my submit button doesn't even show up on this particular Android device. And so Test Cloud allows you to do that, and it allows you to do that in an automated way. And you can put that into your continuous integration environment. So as a step, so you check in your code, and your build server builds it and runs your unit tests, and then if those unit tests pass, then it uploads it to Test Cloud, and then your tests run there, and then your test results come back into your CI system. So as you're integrating, as you're continuously checking in and whatnot, you can get real-time feedback on your changes on real devices. And you don't have to invest in all of that infrastructure to get these thousands of different devices and whatnot, and then build all the code to do all the analytics, etc. So that's a new product that we're coming out with. It's actually in beta right now. So if you want If you want to sign up for that, you can go to xamarin.com/testcloud and get a beta invite. And just tell them that you're from Denmark, and so that you're Denmark, your Danish brothers built it, so so you should get priority. So, okay. Now we understand, if we're going to build we're going to build an app. We understand a lot of the sort of design considerations and planning, and also some of the SDLC things. So now I want to jump in and talk about mobile app architecture, and we'll talk about some recommendations here with Xamarin. So first of all, I've talked about how mobile applications are different. They're different in form factor, they're different in resources, etc. And this might lead you to believe that mobile architecture is different. Maybe there's some fancy new way of building things. And I just want to dispel that right now. So everything that you know about good architecture that you've learned over the many years of doing this is still valid. So good architecture is good architecture, whether you're writing a web application, a desktop application, or a mobile application. And in fact, if you want to maximize your code reuse and maximize your maintainability, then you need to be creating good architectures. And the way that code reuse in mobile apps with C# works is that your UI code is specific to your platform. So if you're creating, let's say we're creating just mobile apps, and we're doing iOS, Android, and Windows. Then we create these 3 different projects, and we create the UI and all of that app layer that's specific to the UI and that integration. And then we create a shared library that is used by those 3 platforms, and all of that code is shared. So things like your business logic, any service integration that you have, so service access layer, so your cloud interaction, data layer and data persistence, as well as data access, all of that stuff can be shared across these different the different applications. But the UI itself, you're still invoking the native UI stuff, and you're still invoking any platform-specific app layer stuff. So, for example, if you're doing animation in Android, then you're using the animation frameworks there. If you're using animation in iOS, you're using the animation frameworks there. And the same thing with Windows, and of course any other app layer stuff. So. Specific backgrounding responsibilities. So backgrounding across these different platforms is slightly different. So that stuff is still specific to your particular platforms, but the rest of your code is all shared. So in order to do that, you still need to do the proper object-oriented stuff. So make sure that you're following good separation of responsibility guidance, and make sure that you're doing proper layering, and make sure that you don't want to be invoking SQL queries from your UI on each one of these. Like that's a no-go. It's the same thing as if you're building a web application. You don't want to be injecting SQL code from each page. Make sure that you're calling into a facade layer or some sort of pattern which encapsulates those things. Otherwise, you're not going to be able to share the code across these different platforms, because you're going to be injecting a lot of platform-specific stuff. And when you're setting up these projects, there's kind of 2 ways to do it. So the essential problem here is that we have we want one shared core library, and then we want different platform-specific projects. Now, how many people here have done Silverlight development? All right, so quite a few of you. So for those of you who haven't done Silverlight development, when you're developing .NET apps for Silverlight, you're using a different core library. So the MS Core Lib is different. And so if you have an application that, let's say it's a Windows application and also a Silverlight application, and you have some shared code, those things are actually building against different profiles of the core lib. And so if you go to add a reference to that shared library, it's not going to work for both of the applications, because that core library might be using APIs that are not available in each of your applications. And that's the same issue in building mobile apps. So there's two ways to get around this. You can either build portable class library projects, and you can publish particular DLL or DLLs that target particular profiles. So for example, you might have a DLL a core lib DLL that targets iOS. You might have one that targets Windows, etc. The other way that you can do this that is much simpler is to use file linking and then use things like conditional compilation. And we're going to take a look at what that exactly looks like. But our recommendation is that generally, if you're building apps, so if you got your mobile app that you're building, file linking should be the first thing that you reach for in your toolkit, because it's going to be much, much easier. And I'm going to show you exactly how to do that in just a moment. If you're publishing components, if you're publishing reusable components across the different platforms, then you should probably reach to portable class libraries, because they allow you to publish a DLL that is targeted for a particular platform. And one of the cool things, I didn't show you this earlier, but one of the great things about the Xamarin platform is that we have an amazing component store. And so this is basically like NuGet, only it's like NuGet on steroids. So when you add a component to when you go to the component store, which is integrated in both Visual Studio and Xamarin Studio, when you add a component, immediately you get not just that component or that DLL, but also you have access to the API documentation for that component, and you also have access to samples and whatnot directly from it. So you add the component, and then you can say, show me a sample. And you click on the sample button, it opens it up, and then it runs it. And you can see exactly what that component looks like and how to use it. So if you're building components that you want to ship to people, we say reach to build platform-specific components using PCL. But if you're just building a mobile app, then you should reach to file linking first. And I want to walk through this, but for when you come back to this slide set later, the deck, this is the way that you set up a new solution. So you create a new blank solution and call it whatever your app you want to, like my awesome mobile app. You create a new C# library project and call it like .corelib. And then you create, if you want to create unit tests for that corelib, then you create your test project. And then you create your platform-specific apps, and then you link the files. And let me show you what that looks like here. So let me pop over into Windows. I'm going to show you this in Visual Studio. And this is the same, by the way, this process is the same whether I'm using Visual Studio or Xamarin Studio. But we'll go in here, and so I say first thing I want to do is create a new project. And I'm going down to here, I want to create a new solution, which is hidden under other project types and Visual Studio Solutions. So we're going to call this My Awesome Mobile App, because if you're not creating an awesome mobile app, then why even bother? I guess we could call it My Mediocre Mobile App, but that wouldn't be nearly as cool. So here we go. I'm going to create this. I'm going to create this somewhere else. I'm going to create it in Projects under Bryan Costanich. Select folder. OK. So here we are. I've got our new blank solution. And then, like I said, the first thing that I want to do is add my shared library. So come in a new project, and I'm going to do a class library. I'm going to call this My Awesome Mobile App.core, or .corelib, whatever you want to call it, or shared or something. Just something that evokes the idea that this is going to be a shared core. And then I don't actually want .core in my namespace usually, so I'm going to go into properties, and I'm going to change the default namespace here. I'm going to get rid of that core. So it's now my awesome mobile app. So now as I go in and I create those different namespaces, if I create my business layer or my data access layer or whatever, it would be my awesome mobile app dot, BL or BLL, whatever your naming convention is for those things. So I'm going to save that. And now, because I'm a good developer, I'm going to create a unit test library. So I'm going to go unit, and file new project, unit test project. We'll call this my awesome mobile app.core.tests. So show of hands, how many people here actually create unit tests when they do? Wow, that's really good. You guys are beating Sweden by far. When I gave this talk in Sweden, it's funny, there's regional differences, but for the most part, I don't think any city had over 50% show of hands of people creating unit test projects. So I think Sweden may be a little more cowboy than Denmark. It's either that or you guys are lying to me. So here we go. I got my core test project, and then I'm going to add a reference to my core project. So I go in, add reference, and add solution projects, and then I choose so this is my core. Hit OK, and now I can write tests against that core library. And the next thing that I want to do is I want to go create my platform-specific projects. So I'll go new project. And I'm going to create my iOS one first, and I'll just create an iPhone app. So we're going to call this my awesome mobile app.ios. Hit OK, and there it is. I think that's my my source control. So there's my iOS application, and next thing I want to do is create my Android application. So add new project, Android, and we're going to call this my awesome mobile app.droid. Okay, so this is really important here. This will save you a lot of pain. Don't create this as .android, because that's going to be your root namespace, and then you're going to get namespace collisions with the Android namespace, and it's going to be a nightmare. So don't do that. Just use Droid out the gate. This was a mistake I made early on, and I will never ever do that again, because namespace collisions are no fun. So here we go. We got our Droid application. And then it creates it. And next, I want to create my Windows store. So I want to go to Windows Store. I'm going to just choose one of these. It doesn't really matter. My awesome mobile app.winstore. You call it whatever you want there. I really wish this were simpler. I wish it were like .mobile, or I wish they were called Windows Mobile Apps or something. I find Windows Store to be a little confusing. So there we are. We got all of our projects set up. We have our core project set up as well. And now we want to, we actually want to share. We want to use that shared code. And so what we'll need to do is that we want to link that project, the core into there. And there's two ways to do this. We can do it manually by file linking. So if I have, for example, so in my core, let's say I want to do, so I'll have my business layer, business logic layer, and then in there I might have like a user class. So we'll say user. So now that I have that class in there, if I want to get that into my iOS project, my Android project, my Windows project, then the manual way is to go in and say, okay, new folder, BL, and then add existing item, and go into navigate to the core, and then grab that class, and then add as link. So that's the manual way. And then now, if I change something in here, so I say, so user, I'm going to say public class user, and I'm going to add like a name property, public stream name, get set. So if I do that, then that code, so it says, if I try to open that in my iOS application, it says, this document is opened by another project, and then it goes into this. So then you get your changes propagated across your different projects, and now you don't have the problem of not being able to reference that class library. So for example, let me show you what I'm talking about there. If I try to go and add a reference to my iOS app, you see it's in here. It'll actually it will actually fail if I try from my iOS app to add to the core. It'll tell me that the platforms mismatch because this is just a C# library, and then this iOS application is using a different configuration. The platform is iPhone, and the same is the case with Windows Store and with Android. So with file linking, I can actually use that code in the different projects. So that's the manual way to do it. The other way to do it is to use the project linker. And to do that, you go into into tools, extensions, and updates. And if you go online and you search for project linker, this is an add-in that's available for both Xamarin Studio and for Visual Studio. The Visual Studio plugin was built by the Patterns and Practices group at Microsoft. And the Xamarin Studio version was just built by someone in our community. But you can add this project linker here. I already have it installed. And then the way that this works, and for some reason, mine's crashing lately. So I had to do manual linking, but you right-click on the project and you say Add Project Link, and then you would be able to choose which project you want to link to. And like I said, I don't know what's going on. I think they've got a bug that they need to fix, because I went on their forums and it looks like a lot of other people are having this issue as well. But you can ignore the error, and then you can still do it, but I don't know if I trust it because of that error.
I have a question.
Yeah.
Why don't you use PCL for the core project? I think most of the tutorials are showing the portable class library.
Yeah. So the question is, why don't you use PCL for application sharing code on mobile apps? PCL is really, really cool in that it's very architecturally pure. But in order to create PCL libraries in real life, it causes you have to create a lot of duplicate code. So even if you're doing the right thing, which you're creating interfaces, and then you do your implementations for the different platforms and stuff, you still wind up with a lot of duplicate code. And even if you don't wind up with a lot of duplicate code, you still wind up with a lot of extra code. And so it requires a lot of architectural judo and a lot of extra work. So we say, don't bother with all that extra work if you're just doing it for an application. But if you're publishing stuff, then you have to. And I hope that this gets easier down the line. One of the things that I'd like to see Microsoft do with their PCL is that you can use conditional compilation, and then it will output the appropriate profile DLLs. So it's something that sort of putting together a proposal to do right now, and that would make things a lot easier. But right now and I'll show you in a bit why this approach is much easier. You'll see that with a few lines of conditional compilation, you can save hundreds or thousands of lines of architectural judo. All right, so so now we have our project linked. So now if I add a new class here, so if we have a user and maybe we have an animals class or something, then this will automatically get added to our other projects. So that's yeah.
So what does the project linker do? Is it just doing some manipulation of the project files behind, or is it changing some of the compilation? How compilation is involved?
So the question is what is the project linker doing? How is it actually working behind the scenes? All it's doing is it's automatically adding linked files. So when you add a new file to a project, then it just automatically links that in. But it's actually the exact same in the project as this manual link. So there's no difference.
So that means that in core,
Mm-hmm.
you're adding files, but the binary built from core is never distributed to the others, right?
That's correct. So you're sharing the code and not the DLL, because the DLL would be targeting a specific profile, which is not compatible with those other projects. So that's that's how you would set up your cross-platform application. And again, as I said, this is the exact same thing as if I were doing this in Xamarin Studio. The only difference is that the add-in for the project linker is up in Xamarin Studio. You go into Add-in Manager. Let me stop that. Go into Add-in Manager, and then in the gallery, you can search for project linker, and then there it is. And there's a bug that I found last night that our refresh of the repositories, the button, our icon disappeared in a recent build. So there is a little icon, there's a little button there to refresh your repositories, and then you'll see that. But it is a little hidden. That's fixed in the next build. But anyway, it's the same thing. The projects, that whole setup is the exact same thing. The one thing that's different with the project linker in Xamarin Studio is that you go up to actually link a project. You click on where is it here? Click on a project, and you do. I forget. I think they moved it actually. Where is the link? I think it's so. I thought it was up in project, but I don't see it there. But when you link a project in Xamarin Studio, then you can actually select all of the projects that you want to link in one spot rather than doing them per project. Like in Visual Studio, you have to go to each platform and you right-click and you say link to project, and then you have to do that for each platform. In the project linker for Xamarin Studio, which I can't seem to find right now because I have jet lag, you just check all the files or all the projects that link to a particular source project. So it's a little bit easier, but it's generally the same thing. So I want to talk. So now we know how to set up our project. Now it's time to actually write code. So I mentioned that you can share your backend code to your application, and you can actually share. It's a typical code percentage for sharing across the three platforms using Xamarin and using Microsoft for Windows is about 80 to 85%. With some other community libraries, people have been able to share up to 95% of their code, which we'll talk about in a sec. But generally, you can easily hit about 85% code sharing, which is really impressive. And the first thing that you'll probably want to probably want to share is your data layer and your data access layer. So it's hard to imagine a mobile application these days without some sort of data persistence. And on iOS and Android, you get shipped the SQLite library, and then on Windows has its own SQL. It has basically the mobile version of SQL Express on there. So how do you share all of that code? Well, we recommend using a couple of things. First of all, you go ahead and use SQLite, the native SQLite implementation that's on iOS and Android, and then on Windows, we actually recommend the C# port of SQLite. And the reason is that you can, by using that, then you have the exact same data access layer code and data layer code across all three platforms. And when we were first making our reference apps, and I was first trying this, I was a little concerned that this port, the C# port, which is an open source project, by the way, up on Google. I was first concerned that maybe the performance wouldn't be good, but it turns out that this thing is nearly as fast as the indigenous SQL database. And in fact, for most scenarios, you won't even notice the difference. Like even when you're running metrics on it and whatnot, the difference is so trivial that there's no conceivable way in which a user would notice this. So by using that C# port of SQLite, then you can share all of your code, and you don't have any bifurcation between these platforms. So you get a lot of value out of doing that. And the next thing that we recommend is this SQLite.net ORM, and this is a mobile-specific ORM that's very, very lightweight and very fast. That makes your data access layer essentially free to create. And that, in conjunction with our reference implementation, which you can find in Tasky, which we've written a generic layer on top of that, can make data access, like I said, essentially free. Let me show you what that looks like here. So let me pop back over to Xamarin Studio. So before I told you that we were going to be looking at that Tasky Pro application. So if you were to pop onto GitHub and grab that, then this is what you get. I've opened this in Xamarin Studio, so it only has the Android and the iOS project in there, but if you open up the Visual Studio solution, it also has the Windows project in there. Obviously, you can't build Windows projects on Mac, so the Xamarin Studio solution doesn't include it. Otherwise, it would say, hey, cannot load this project every time, and that'd be kind of annoying. But if you go into the Tasky.core project and you drill down into the data layer, there's a couple of things. The first one is, here's this SQLite.cs file, and let me zoom out just a bit. So this is the ORM that I was telling you about. So it's basically just a drop-in file. And here's a place in which conditional compilation is used to specify code paths on the different platforms. And so this makes it super easy to target the different platforms. And you notice on one of these, if we're using the C# version, then we don't have this. Our handles are just null. And then if we're using the indigenous one on iOS and Android, we're actually passing an int pointer because we're doing pinvoke, where as opposed to a C# method invocation. So if you scrolled all the way down here at the bottom, you can see. Here's the regular C# stuff in which we're doing, in which the p invokes are happening rather than just direct C# calls. So this library then becomes, it's all in one file, and we don't have to break out those implementations into different classes and whatnot. And as an exercise, so this was written by a guy named Frank Kruger. And Frank Kruger is a very active guy in the Xamarin community. He wrote iCircuit and Calca. iCircuit is like a circuit emulator application for Android, iOS, and Windows. And what it allows you to do is drop on like transistors and resistors and different ICs and stuff, and then actually model it and run it. And it's one of the best-selling Apple like App Store apps. And in fact, Apple liked it so much that they put it on all the iPads in the app stores. And it's really cool. Now he's got this thing called Calca. And Calca is like a natural language calculator. So you create these text files, and then it parses these text files and then does calculations and stuff. It's really amazing. Anyway, he wrote this SQLite ORM. And we, as an exercise into looking into the PCL story here, we actually took this and broke it out into a PCL-friendly architecture. And you can actually find that in our repository. It's called Tasky Portable. And you can see that the judo necessary there from an architectural standpoint was insane. I mean, there's just so much duplicated code and whatnot. And it becomes very complex. And then maintainability is like a much higher cost. So if you drop that in, and then the way that ORM works is you attribute your files with primary, like, so for example, for your primary key, you attribute it with primary key auto increment, and that's essentially it. Now all of the translation of your entities, your business entities, to the database is essentially free. It's very powerful, but it doesn't require the overhead of doing like entity framework or and hibernate with Fluent, etc. It's very, very cheap and very easy. And if you look at this task database implementation, which is the thing that I was pointing to in the presentation, what we've done is we've written a wrapper or another layer on top of this, which exposes all of your basic CRUD methods, so all your create, read, update, delete stuff generically, so that you can pass in T, where T is like this iBusiness entity. And if we look at this iBusiness entity, it has an ID, which is an integer. And if you wanted to use a GUID or something, you could modify that to use that. But if you follow this pattern, now to do database access, your get items, save item, delete item, all those, all of your basic methods now become essentially free. So if we looked at the data access layer here, and we're exposing these in a strongly typed way, so we have this task object. So this is for Tasky. So the to-do item is represented by a task object. And so to expose like get task or get tasks, it's very simple. We're just calling into that database and that task database class, and we're using those generic methods. So if we had users, etc., it would be the same thing. All we have to do is me.db.get items, and you pass, and of type user, and then it would return all of your users. So now you have all of your basic data access for, in no time. Like literally, it takes you about 5 minutes to drop this in and then create your entities, and you can have a fully functioning data access layer and data layer across all 3 platforms. And it literally takes like 5 minutes to do this. So this is like a great pattern to follow. And here's another case, by the way, in which we're using conditional compilation. So in this case, on each of the platforms, where you want to save the database is slightly different. So on iOS, In iOS, it goes into your environment.special folder.documents, and then in Android, it goes into like environment special folder library, or no. So library for iOS, and then personal, special folder.personal for Android. And so, yeah, go ahead.
Question?
Yeah.
So basically here it was calculation. I see here like 3 different results of this calculation, right?
Yes.
How do you test it? How do you test the 3 different?
So the question, so we've got 3 different paths here. How do you test this? It's easy. You just you deploy it to your 3 different platforms, and if your database works, then.
About unit test.
What's that?
I'm speaking about unit test.
Okay, so if you're doing unit tests and you want to test this in unit test, then we have actually unit test frameworks for the different platforms. So, and there's a document up on our docs website on how to set that up. But there's a unit test framework for iOS, and there's a unit test framework for Android. So you can actually run these and unit test them. So yeah, so there's your data access layer and your data layer in like essentially like 5 minutes, which I think is really, really cool. So we've sort of sprinkled this throughout the talk, but now we've got our data layer set up, we've got our solution set up, and now we're actually creating the rest of our application. And we need to handle platform divergence, both between the platforms and then even within the platforms. So I want to dive a bit and talk about how to do that. The first one, we saw this, and I showed you how we were doing this, is conditional compilation. And this, you look over here, and this is actually sort of some older symbols, but now we have mobile, Android, iOS, and then Windows Phone. And mobile is a common target between Android and iOS. And as we build out Windows libraries and stuff, then at some point we'll include that in there as well when we ship the reference libraries that extend our profile target to Windows. And then Android is obviously for the Android and iOS, and then Windows Phone is like Windows Store apps. So you can also very easily create your own or define your own symbols. So if you just go into build settings and you select your configuration, so your platform and then also your build type, whether it be debug or release, then you can define symbols there. So then you can say, if debug iOS, etc., and then you can have different compilation paths that way. And like I said, this is for when you're building an application. This is what we generally recommend: is that you do the file linking, so that you have your shared code, and then you have these different code paths here via conditional compilation. The other option here that you have is to do like a PCL route, or even if you are doing, even if you're doing file sharing and whatnot, you can still do this. You can do your tried and true architectural abstractions. So you can create interfaces, and then you can create platform-specific implementations that conform to those interfaces. And like I said, to see this in action, take a look at the Tasky Portable example. And what this does is it creates an interface for your database access, and then we've got the implementations for the different platforms. iOS and Android are shared, and then Windows is different. And there's one of the patterns that people like to follow here is you can either use inversion of a control or you can use a provider pattern. Inversion of control and provider pattern are essentially the same thing conceptually. Provider pattern is a Microsoft coined term. I think Patterns and Practices group came up with it. But it's so if you're familiar with like ADO.NET, you know that there's an IAODB interface, and then there's like IOLADB or whatever, and then there's all the different ADO.NET providers. So there's one for SQL, there's one for Oracle, etc. So the idea between the provider pattern is that you have one interface, and then you have different pluggable providers that would provide the particular implementation on whatever platform or whatever technology you're trying to talk to. And that's a compilation time or design time pattern, in that you choose what you're going to use at compilation time. And then the IOC stands for inversion of control, and their simple dependency pattern is conceptually the same in that you choose an implementation. The only difference is that with IOC, it's a runtime decision. So at runtime, you can decide to use a different implementation. And for mobile applications, there's a library called TinyIOC, and allows you to use this IOC pattern on a mobile device, on these mobile platforms, and it has the framework all set up for you. So you just have to use that, and then you can do your dependencies that way. But like I said, this is generally, when you need this, is for doing portable class libraries. And you can, while this is very architecturally pure, it does require sometimes considerable extra work, but is necessary if you're shipping libraries. So then, oh, my fancy animations. So the other thing is that there's a bunch of cross-platform libraries out there that provide cross-platform abstractions. So it gives you a single API across the different platforms. We've open sourced and shipped several things that are Xamarin blessed, and you can find these up on github.com/Xamarin, Xamarin dot whatever it is. So we have mobile, social, and auth. And .mobile contains things like camera and photo access. And then social has things like Facebook and Twitter, and then also Weibo, which is the Chinese version of Facebook. So if you're building your democracy app and you want to export that to China, then you can incite a revolution via Weibo. But for the rest of the world, then you're probably using Twitter and Facebook. And then auth has like OAuth libraries for SSO and stuff. And so these things, like I said, they're open source. So you can go in and you can look at how we've done it. And also, if you need to modify it for your own use, then you can just dive into the code and add new features or change features as you see fit. There's also a number of other community libraries out there. I said that our community is awesome, and I really meant that. There's a couple of UI, like cross-platform UI frameworks. Monocross and MVVM Cross are a couple of big ones. These basically, they extend that code sharing into the UI layer. Now, Monocross is this is good for doing, like I talked earlier about those form sort of form field or form building apps in which you've got just some database access or whatever, putting in data entry. This is kind of like a one size fits all, but not quite. But it's a little more limited. So if you're doing a form entry app across platforms, then Monocross is a way to do that and to get this and just reuse your code, your UI code across those different platforms. MVVM Cross is the same idea conceptually in that you take your shared code and you include your UI code in that. But what it does is it takes the MVVM pattern, which you're used to on Windows Store apps and WPF and stuff, and it provides that on iOS and Android. And so like your reactive UI type things, when you have the data binding, automatic data binding and whatnot to the UI, so it pulls that over and allows you to do that pattern on iOS and Android, and then actually use all the same or nearly all of the same UI code. And the big difference between MVVM Cross and Monocross is that MVVM Cross still does like a very native implementation. So it's different for each platform, even though it's the same code. They sort of tailor it to each platform, and then you can dive down and do platform-specific things. Now, MVVM cross takes a bit of time to set up. There is a sort of upfront cost to it, and also a learning curve. But people are shipping apps that have like 95% code sharing with MVVM cross, which is really incredible. I mean, to target iOS, Android, and Windows Store apps and have like 95% of your code being the same, so only changing 5% of your code, and that's amazing. That really allows people to target these different platforms for very little effort. RDO is one of our customers. How many people are familiar with RDO? So a couple, yeah, I don't think it's available here, but RDO is, how many people know Spotify? Okay, so RDO is like Spotify, only like way, way, way better. Don't believe me though, the Wired did an article about the mobile music subscription apps, and they just blasted everyone but RDO, because RDO's interface on the mobile experience is amazing. It's really, really incredible. I love RDO. And RDO is built on Xamarin. So they have Windows, Android, and iOS versions, and they have like shared code, and it's all the C# powered and stuff, and it's really an incredible application. But one of the things that they've done is they've open sourced their localization library, and this is something that is important, obviously important in Scandinavia, because you guys have to, there's not a lot of people in the world that speak Danish. So localizing your app is oftentimes important. In America, we're like, whatever. You guys can also speak English. We don't care. But so there's not a lot of localization efforts in the United States, unfortunately. But for the rest of the world, localization is important because there's a lot of markets that you publish an application, even if you do it in English, it's not probably going to be used so well in China or in the Congo. So the localization is really important, and vernacular is amazing because this is a cross-platform localization framework that even if you're not doing cross-platform apps, their API and the way that they do localization is so nice. It's nicer than the localization framework on any of the platforms themselves. So even if you're doing one platform, I recommend vernacular. And definitely if you're doing cross-platform apps, vernacular comes highly recommended because you've got now one API for localization across all three platforms, and it's very, very elegant. It's very nice. So Monogame, I talked about this before. Monogame is an open source version of the XNA toolkit. Now originally, this was intended to just run on Mono. But then Microsoft decided to discontinue the XNA toolkit, and now they're pushing people to Monogame. So Monogame is actually maintained by Xamarin employees, and this allows you to write games that target a number of different platforms. And the most amazing thing about Monogame is that in games, you don't have the write once, run anywhere limitation because you're doing UX typically that is specific to your game and not specific to the platform. So a game, it's okay to have the exact same look and feel across the different platforms. And so Monogame allows you to use the exact same code across a number of platforms. So if you build a phone game or tablet game in Monogame, or XNA, then now you get free deployment to all these other platforms. The same form factor. I mean, you can even scale it and stuff if you want. So this is really, really, really powerful for game developers, and there's a ton of best-selling games in the app stores that actually use this. So I highly recommend this. It's pretty amazing. And there's this another library called Cocos 2D, which is being renamed to Coco Sharp, and this is built on top of Monogame. and adds a lot of other game-specific code. So there's some like game engine stuff and physics libraries and networking and stuff that's game-specific, and that's that runs on top of MonoGain. And so it's really, really cool. A lot of people are building really neat games. In fact, if you go to cocos2dxna.net or MonoGame sites, you'll see that they have a whole portfolio of games and games that you wouldn't even I was surprised when I went there. I was like, oh, that's cool. I like the game. I didn't realize that was built on this. So it's very, very powerful. So like I said, our community is awesome, and there's a lot of great cross-platform API stuff there. So that's the deal. That's Xamarin, and that's how you build mobile. Cross-platform mobile apps. So I recommend going to Xamarin.com and download it and try it and go start building mobile apps and go build mobile apps that share code. So yeah, that's it. Get building. So let's I think it's time for you guys have any other questions, fire away and we'll chat. We'll talk about this. Anything that was unclear or whatever. Right here.
Could you revisit, please, the topic of UI testing that you mentioned?
Yeah, okay, so the question is, can you revisit the topic of UI testing? So generally there's kind of two parts. One is it's important to test early and often on the actual devices that you're deploying to. And the second part of that is that we've made that incredibly easy with Test Cloud. And Test Cloud is a cloud-based service. So basically, up in Aarhus, in the data center there, we have thousands of devices, and you can upload your application and upload your tests to those devices, and they automatically run. So the way this works is that you go to the Test Cloud site, you upload your application, you upload your tests, and then you choose which devices you want to test on, and then you hit the button and it deploys to all those devices and runs your tests, and then gives you the results of those tests. And the way that tests work, let me see if I can. Let me actually pull one up here. Let's see. So we're going to ship this soon. This is a Calabash. So this is our Calabash samples. Let me show you what this looks like. Sam code, private samples, Calabash. Okay, so the way that Cucumber works is that in your project you create a features directory. And then you have steps and step definitions. And by the way, right now this is Gherkin and Ruby based, but we're actually creating a C# version of this as well using SpecFlow. And let me show you what SpecFlow looks like. SpecFlow is really, really cool because it allows you to attribute your classes with your, let me see if we have a, using Gherkin language and Wiki SpecFlow. I think Wiki has a great, here we go. Yeah, so your Gherkin, so the way that Cucumber tests is that, or Cucumber tests work, is that you write these business. You write tests in a business language, which uses the Gherkin syntax. And so the Gherkin syntax looks like this. So it starts with a sort of feature definition, and then within a feature definition, then you write individual tests. And so here's one: story, or this would ordinarily say feature. Returns go to stock, so this might be returns. And these different testing scenarios. So scenario 1, refund items should be returned to stock. Given a customer previously bought a black sweater from me and I currently have 3 black sweaters left in stock, when he returns the sweater for a refund, then I should have 4 black sweaters in stock. So you write these tests, your application tests using this natural language, and then later on you have to actually define how those execute. And with SpecFlow, you can attribute your classes with these, with basically what's a regex expression. So it matches that expression, given that I have to return these shirts, and then you implement your testing using a strongly typed API that exposes your UI elements and whatnot. And so SpecFlow is the future of what we're doing with the C# version, but right now you write these in Ruby and Gherkin. So here's one. So this Calabash examples. Let me switch this to iPhone. Let me see if I can run this. I haven't tested this lately, so. Oh, that's not what I want. I don't want Droid. I'll set a startup project, iPhone. All right, so there's an error in it right now. But basically, so the Calabash, so this examples project has a bunch of like common scenarios that you want to test. So one of them is a credit card entry screen. And so this credit card feature, there's a credit card validation feature. And if I open this up, so open up, let's open this with text edit. So feature credit cards. Credit cards should be validated before moving on. And there's a couple of different versions. There's lots of different ways to write these things. Test Cloud Calabash actually ships with a bunch of predefined steps. So you don't have to go and build your own step definitions. So you can say scenario credit card number too short. So take a screenshot. When I touch credit card validation, and this is an ID or a label ID on the screen, and I use the native keyboard to enter 1, 2, 3, 4, 5, 6 into text field number 1, and I touch the validate button, then I don't see the valid credit card. So these are your step definitions, and that's one using the predefined steps. Here's one in which you would use a custom steps in which you create your own. You got to run. All right, so we're going to wrap this up real fast. So you can also write your own custom steps in which you use a more sort of business-friendly language here. So given I'm on the credit card validation screen, blah, blah. And then you create these step definitions on the back end. So we look at this credit card validation steps. Let's see if I can zoom in. View. I don't know how to zoom in Xcode. Now you write some Ruby tests, some Ruby code on the back end that translates that Gherkin into actually executable steps. So given, and there's our regex. So do a screenshot, touch the view marked credit card validation, wait for the animation, so sleep, and then take another screenshot, and then it goes on and so forth. And so what this does is that you can then run these, and it will automatically deploy to the devices, and then click on the screen, and then validate that the appropriate actions happened, and then you can get your results that way. So it's a really powerful way to do UI automation testing and make it automatic, and then deploy it across a lot of different devices. Yeah. So.
And do you currently support all of the platforms for implementing the steps?
So the question is, do we currently support all the platforms for implementing the steps? So Test Cloud supports iOS and Android right now, and we're going to be adding the Windows to it next. And over here.
Assuming I have a failure on one of the devices, will I be able to debug that device?
So the question is, assuming that I have a failure during testing, will I be able to debug on the device? No. The idea is that you would send it off into the cloud, and then you would get results back. So then you would have to go and then you would want to, then you would have to step in from there and figure out, okay, why did it fail, and go from there. But currently, there's no way to debug those devices in the cloud. I think we have to wrap it up here. I think we're running short on time. So, thanks, guys. I hope you guys liked what you saw today, and you're going to go out and try Xamarin and start building mobile apps with C# and Arduino apps and stuff. That's cool. Agent Watch apps and stuff. So thanks, guys.